Chapter 13, Section 10, Exercise 2. We are going to find the maximum and minimum sums of coordinate pairs of points on the circle of radius 2 centered at the origin. We will use the method of Lagrange multipliers. We get 3 equations and 3 unknowns. The variable lambda is called by some a dummy variable. Technically, it's called the Lagrange multiplier. Now, elsewhere in this handout, I do discuss the meaning of the value of lambda. However, we only really care about solving for x and y. So, we can first solve for lambda in terms of x and y in order to remove lambda from the equations. Here I've picked some random points on the circle of radius 2 centered at the origin. I have not bothered to find their coordinate values, but this is what we're trying to do. What is the value of the sum of the x and y coordinates at various points around the circle? What we want to do is determine the maximum and minimum values of x plus y, that is the sum of the coordinates, subject to x squared plus y squared equals 4. In other words, we are optimizing f of xy equals x plus y, subject to the constraint g of xy equals x squared plus y squared equals 4. We solve the partial derivative of f with respect to x equals lambda times the partial derivative of g with respect to x. Likewise, we have a second equation with the partial derivative with respect to y. The third equation is the constraint. The partial derivative of f with respect to x is clearly 1. The partial derivative of g with respect to x is 2x. We can write this, since both lambda times 2x and lambda times 2y are equal to 1, so they are equal to each other. Dividing both sides by lambda times 2, we get x equals y. Bring in x squared plus y squared equals 4, and the fact that x equals y, we get and since x equals y, f, which is the sum of the coordinates, evaluated at square root of 2, square root of 2, this is the max sum of the coordinates on the circle. Here we have the minimum sum of xy coordinate pairs on the circle of radius 2 centered at the origin.